Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Hayyan Sibai. I'm happy to be here with you to introduce the model of Mooc FTech. I am from UNB FTech, Faculty of Engineering Technology. I will produce to you today the part 3 of module 1, which is Introduction to Basic DC Circuit Analysis. I hope by the end of this module, you will be able to understand how to analyze a mixed series parallel circuit and to understand the importance of circuit analysis. So let's begin with the introduction. What is the series parallel network? So how to define series parallel network? So it's clearly from its name that series parallel network is can be configured as one that is formed by combination of series and parallel elements. So let's see an example. As you see in this example, we have series and parallel elements. I think you are already familiar if you finished part 1 and part 2, what is series and what is parallel. So series parallel network is a combination between series and parallel. We should differentiate between series parallel and complex configuration. Complex configuration is the one which is not of the element are in series or in parallel. For example, this one. So you see a resistor in the middle, actually it's not in series, not in parallel with the other things. There are different ways for analyzing this one. We will come with this by the end of this module. But now we are still in the introduction. So let's understand some basic concepts relating to this class or this module. First, what the branch, then we will speak about components between these two terminals and the analysis of a circuit. So branch actually is a part of circuit that can be simplified into two terminals. So any two terminals, if you have a circuit, if you can find two terminals, this is called a branch. Now, components between these two terminals can be resistors, voltage sources in our course, and if we are taking DC or other things, it's maybe any other elements. So how to analyze a circuit? To analyze a circuit, actually, we need to identify elements in series and elements in parallel. So this is what we mean by analyzing. Analyzing actually is to find what elements are in series and what elements are in parallel. Actually, in electricity, Ohm's law is controlling everything. So Ohm's law, we have V, I, and R. Okay, voltage, current, and resistor. So finding these three elements is the basic, the target why we are doing analysis. Let's have an example how to analyze a series parallel circuit. So if we look at this circuit, actually we start to combine elements in parallel and in series. So we start with R2, R3, and R4. Actually in this circuit, RT, R3, and R4 are in parallel. So next step is to combine them as one resistor, as you can see here. We call it, for example, R prime. So now this new element is which is the parallel combination, is actually in series with R1 and R5. So in this let's see another example. In this circuit, now as you can see, R4 and R3 are in parallel. If we combine them, the result will be in series with R2. And the whole branch, R2, R3, and R4 is, this complete combination is in parallel with R1. So this is actually how we proceed step by step for circuit analysis. Of course, we should be careful. It's not always easy from the first glance to understand that this circuit is series or parallel. So for first glance, for example, you may think that R5, R6 are in series. Actually, they are not. Let's consider the 2 points, 1 and 2. So as you can see here in the 2 points, 1 and 2, actually they can be considered as 1 point. Have a look, okay? So again, 1 and 2, if we look at them carefully, actually this can be redrawn like this. So now, if you look to this circuit, I think you can imagine better. Now, it's clear that R3 and R5 are in parallel. R4 and R6 also are in parallel. So the result of R3 parallel R5 and R4 parallel R6 will give us the correct answer. The final relation is all are in parallel with R2. And then the result is in series with R1. So now what do we mean by analysis of parallel circuits. So rules for analyzing series and parallel circuits still apply. Actually, whatever you learned for series and whatever you learned for parallel is applied for the combination of series parallel. So that's like the content of this is that first, some same current occurs through the series element. So in the series element, as you studied in the part 1, the current is the same in all parts. The second rule, the important rule, is same voltage occur across all parallel elements. That means all elements in parallel, they will have the same voltage and the current will be different. So always remember as this. In series, current is the same. In parallel, voltage is the same. Now, you already have an idea about KVL and KCL, Kirchhoff voltage law and Kirchhoff current law. These two laws are applied for all circuits, whatever they are, series, parallel, or series, parallel. So, now, putting these three rules in mind, it's better to practice techniques. Actually, through this module, what is our job is to practice and master these techniques. So in this, since we are just doing introduction, so I just go through them quickly. So one of the techniques that you should master and practice is to redraw a complicated circuit showing the source at the left hand side. So always try to move the source to the left hand side. As I said, I am just mentioning what are the techniques today, and later on in the next parts and modules we will practice how to use them step by step. Next, always keep in your mind to label all the nodes. Always develop a strategy. You should have a strategy to solve the problem. Always best to begin analysis with components most distance from the source. So again, what we do, we put the source at the left hand, redraw complicated circuits showing the source at the left hand, label all nodes, and start with components most distance from the source. Try to simplify recognizable combinations of components. So if there is clear that these parts are parallel, these parts are series, try to simplify them and redraw the circuit. Determine equivalent resistance RT. So simplify and find the RT. Always our target in series parallel analysis is to find RT. Why? Because using RT we will find I and V, which are the components of electricity using Ohm's law. Finally, solve the total current. Actually, not finally, just solve the total current. After finding RT, you need to solve the total current. Then label polarities of voltage drop on all components. Okay? So, just to go back again. So, try to simplify things. Find RT, R total, solve the total current, then label polarities of voltage drops on all components. Try to calculate how currents and voltage split between elements in a circuit, okay? Using current divider and voltage divider rules. And always, there are not only one way to find the correct answer. So always try to verify your answer by taking a different approach when feasible. So if it's possible to try another way to solve the same problem, do it to make sure that your calculation is correct. And always remember, for voltage, use Ohm's law or voltage divider rule. For currents, use Ohm's law or current divider rule. So in series, parallel, it's a combination between series and parallel. So all the rules are applicable. And as I said previously, current always the same in series, voltage is always the same in parallel. Then we can use Ohm's law and voltage divider for voltage, current divider for current. So let's summarize what we study in this part of the module. First, we defined what is the series parallel. So series parallel configuration is one that is formed by combination of series and parallel elements. If we have series and parallel combination of resistors in DC, this is a series parallel network. One important thing that we should keep in mind through this module is rules of analyzing series and parallel circuits still apply. So combining will not change anything. It's always apply for all part where we find series, we apply the series rules. Where we find parallel, we apply parallel rules. Finally, always practice to use good techniques and try to simplify your solution whenever you can. Always try to make it step by step. Don't find RT from the beginning all. Find RT for parallel elements, for series elements, and combine them step by step. Like this, we finish this part of our module. I hope it's beneficial for you, and it's, as I said, it's introduction, and we will going to actually practice how to use these rules and techniques after that. Thank you for listening. Thank you very much.